Hello and welcome to another Symphony tutorial. In this tutorial, we will see how to create simulations with the help of fields and controllers. So let's begin. First of all, let's go through the electric field. To create a field, just right click on your mouse and select World Settings. Here on the top, click on Fields. Then you will see the Add Field button. Now here you can see all different types of fields. Let's select electric field. Now here you can give the field a name for script functions. Now here we have to enter a function to specify the x and y direction intensities of the field. You can also use this virtual keyboard for the same. Now for example, let's specify it as 2i cap plus 3j cap. Here you can also select the color of the field. Let's take it as green. The bounds option allows you to set bounds of the active region of the field. You can select any of the following shapes for your field. Let's take it as rectangular. Set the height and width of the region. Let's take both of them as 4 units. By clicking on transform, you can specify the center of the region. Let the center be situated at 2, 2. Just click on set and then apply the field to the world. Now here you can see the electric field in a bound region with the vectors indicating the field intensity. Now let's create a free gravity world by clicking on toggle gravity button as we want to experience the effect of electric field only. Let's create a charge of 5000 microcoulomb to see the effect of electric field. You can also create different scenarios depending on your need. Now let's take an example of a varying electric field. You can edit or remove the field by clicking on the field in the object table. Now, let's create a variable electric field of say minus 10x I cap, minus 10y j cap. For this purpose, you can also use the virtual keyboard. Let's transform the center of the region to 0, 0. So here you can see the variable electric field region. So in this way, you can add field to your simulation. Now, let's move on to magnetic field. Now, to create magnetic field, repeat same steps and now select magnetic field as the field type. Here you can set intensity of the magnetic field which would be pointing towards that direction. Let's take it as 100 Tesla. Negative indicates that the direction is towards negative z-axis. Let's keep the bound same and then apply it to the world. Here you can see the specified region with magnetic field pointing inside the plane. Now let's create a negatively charged body with a magnitude of 5000 microcoulomb and provide an upward velocity of 3 meter per second. Now let's test it. So this is how it works. Let's move on to next example of variable magnetic field. Now let's change the intensity of the field and make it vary with x and y. Let's use the virtual keyboard and take an expression say 2 sine x plus y. Let's transform the center to 0, 1 and then apply the new expression. Now let's play this and see how it works. So in this manner we can apply a magnetic field to our simulation. Now let's move to gravitational field. You can see the bottom left corner indicating the gravity of the world. You can change the gravity by using the gravitational field tool in the tool window. You can specify the gravity by just dragging your mouse to a specific length in a specific direction. You can also reset gravity to default value by clicking on Reset Gravity button at the top left corner. And you can also toggle gravity by using Toggle Gravity button. You can also hide gravity by unchecking the Show Gravity checkbox. Now go to Fields Here, also you can alter the world gravity from above. Now, to create a bounded gravitational field, select field type as gravitational field. Let's specify the x and y intensities as 9.8 meter per second square each. Let's set the height and width of the region to 6 units and then apply the field. Now, create a body and place it in the field. Remember that the field inside the region is resultant of the specified expression and the world gravity. So, resultant gravity inside the region would be 9.8 I cap. Now, let's test it. So, as you could see, the body first moved horizontal and then under the influence of world gravity. Now, let's take another example. Let's take a variable gravitational field, say minus y I cap minus x j cap. Toggle the gravity for our gravity field 1. Now, let's create a body and place it inside the region. Let's specify the position of the body to -2, -2. Now let's run the simulation. As you could see, the body executes to and fro motion inside the region because of the specified expression. This is how you can create a gravitational field. Now let's take a look at buoyancy field. To create a buoyancy field, go to Fields and then select buoyancy field as field type. Here you can specify the density of the liquid. Let it remain 2 kg per meter cube. You can also define the drag coefficient, which is the measure of drag offered by the liquid. You can also provide lift coefficient and velocity of the fluid. Let it be 0. Now set the height and width of the region to 4 units each and apply the field to the body. Now create a block and then play the simulation. Now, as you could see, the damping of the block, which is due to drag force applied by the liquid. Now let's change the fluid velocity to 2 I cap and see the changes. Here, you could see that the block got carried away with the flow of the liquid. So, this is how we can create buoyancy field. Now, let's see how to produce forces and torques. To add forces, right click on the body and go to Actions and select Apply Force at a point. Here, you could see that we can enter the value of force in x and y directions. Let's say it for example to be -2x I cap minus 2y j cap. You can also define the point of application of force. Here, coordinate system is defined with respect to the body. And you can also select different modes of application from the list. Let's select the first one with fixed point and direction and then apply the force. Let's play the simulation. Now here you can see the effect of force on the body. Now let's go to an example to apply torque. Let's apply a torque to the back wheel by clicking on Apply Torque. Let's apply a time varying expression, say 2t. This is how it works. The torque gets increased with time. Now here you can also use different variables in your expression, that is time, coordinates, angular speed, angle, and velocity with its components. In this way we can apply torque to a body. Now let's go to body controllers. The basic difference between actions and controllers is that actions can be influenced by other actions, whereas controllers cannot be interrupted by any obstruction. They just follow the expression specified by us. Now let's apply a position controller to a body. Let's say it as 2 sin 2t I cap, 2 cos 2t j cap. Now here you can see that the body didn't collide with the ball. This is because controllers cannot be influenced by any external forces. Now, in similar manner, you can add velocity and acceleration controllers. Let's apply angular controller to the body. Say it has 2 theta plus 1. This is how it works. Now let's see the property controller. Here you can select property and provide a value to it. Let's say moment of inertia to be 2 kg meter square. Now here you can see that property changes in dynamic window. So this is all for this tutorial. Thanks for watching.